Hey everybody, and welcome to the Rakuten SixthSense series of product webinars. I am Supriya Ghosh, your host for the day. A brief of myself: I work as a senior product manager at Rakuten SixthSense and am responsible for building various observability products. Today, we will be discussing on the topic API security and its fundamentals. We will cover the basics of API security, its importance, and the common threats that API face. So in the rapidly evolving digital ecosystem, the seamless integration of systems and services that happens via these application programming interfaces, or APIs as you commonly know, is just not a convenience but also a necessity. This webinar dives deep into the world of APIs and explore the critical role, their inherent vulnerabilities, and the paramount importance of securing them against today's escalating cyber threats. As we dive deep into the essence of APIs and the security, we will also underscore the imperative to shield the data that vary across this digital realm. APIs have often become the linchpin of digital transformation. They enable the connectivity and communication necessary for modern applications to function efficiently and effectively, from facilitating transactions to connecting disparate systems or even enabling new business models. API plays a pivotal role in today's digital landscape. However, this widespread adoption has also brought in significant security challenges. As API opens up the internal systems to external developers, partners, applications, third-party known and unknown users, they become the prime attractive target for cyber attacks. Therefore, understanding and implementing robust API security measures is crucial for protecting organization data and maintaining the trust of users and stakeholders. So before we dive deeper, let's quickly check what are APIs and what they exactly do. So at the heart of digital innovation, APIs facilitate interactions between various software applications, acting as a gateway for data exchange and information exchange alike. They allow different software systems to communicate with each other seamlessly, enabling the integration of various services and creation of complex interconnected ecosystem. APIs can also be called a bridge that connect different pieces of software, allowing them to work together to perform tasks that none of them could have individually done. This ubiquity across customer-facing, partner-facing, and internal application often exposes these APIs to a myriad of security threats and makes API security a cornerstone of digital trust and integrity. APIs essentially enable different software systems to communicate with each other, thus making them vital for both internal and external operations. APIs are used in various scenarios, from enabling the functionality of web apps or mobile apps or even connecting IoT devices, thus facilitating this machine-to-machine communication in industrial settings. However, the very fact that API exposes application logic and sensitive data, including PIIs, makes them a beacon for cyber threats. Gartner, as per 2023, reports that 90% of web-enabled applications face a greater risk of attack through exposed APIs than through the user interface. This statistic alone underscores the critical nature of securing APIs against potential threats. So as APIs continue to provide direct access to backend systems and the relevant data, any security flaw can be exploited to gain unauthorized access, leading to data breach and various other cybersecurity incidents. So why are APIs vulnerable? A recent survey actually showed that 90% of CISOs worldwide feel that the rapid adoption of digitalization has created unforeseen security risks. And 95% of them also believe that amongst all the security risks, supply chain and APIs top the list of security control gaps resulting from this digitalization. So APIs are particularly vulnerable to security threats for various reasons. One, they are the direct pathway to data. As APIs offer direct access to an organization data vaults, including sensitive information, they become the prime target for cyber criminals. Since API provides a direct interface to backend systems, they can also be exploited to access sensitive data if not properly secured. which makes API a lucrative target for attackers trying to steal data, disrupt service, or gain a foothold in the organization's network. 2. Overlooked security. Despite rigorous firewall protections, API has often remained the Achilles heel of our digital defenses, thus providing a very less guarded entry point for attackers. Traditional security systems such as WAFs and firewalls are often focused on protecting the network perimeter. However, API exposes a different attack surface that requires specialized security measures. Without proper attention to API security, we have seen organizations often leave themselves vulnerable to attacks that can bypass these traditional defenses. Third, complexity and interdependency. Yes, the complexity of modern APIs, which often involve multiple endpoints, multiple integration points, often increases the potential for security gaps. Each endpoint and integration point can introduce new vulnerabilities if not properly secured. Additionally, these interdependencies between different APIs and systems can create cascading security risks where a vulnerability in one API can compromise the entire connected system. 4. Rapid development and deployment. In the fast-paced world of software development, APIs are often developed and deployed rapidly to meet business needs. This can lead to security being overlooked in the favor of speed, speed, speed. When APIs are developed without proper security consideration, they often become the targets for attackers looking to exploit vulnerabilities in the code. The safeguarding of data transmitted via APIs often hinges on stringent security protocols, which encompasses measures like authentication, authorization, encryption, and continuous monitoring. These measures are vital in thwarting unauthorized access and mitigating threats like SQL injections, which thereby increases the resiliency of digital ecosystem. So how is API security different from traditional web security? Well, there are different in several key aspects. One is the attack surface. APIs often have a large attack surface than a traditional web application. This is because APIs can be accessed by a wide range of clients, including mobile apps, IoT devices, and even other systems. Each client that accesses an API represents a potential entry point for an attacker. Unlike traditional web applications, which typically have a single user interface, API exposes multiple endpoints that can be targeted by these attackers. This increases the overall attack surface and makes it even more challenging to secure all these entry points effectively. 2. The authorization and authentication. Yes, APIs also typically rely on different forms of authorization and authentication, which are different from the traditional web apps. Yet API uses OAuth or JSON Web Tokens, which are commonly known as JWTs, to authenticate and authorize clients, which means that traditional web application security measures such as session management may not be sufficient for API security. APIs often require more granular access controls to ensure that only and only authorized clients can access specific resources and perform specific actions. Implementing robust authentication along with robust authorization is crucial for preventing unauthorized access to APIs. 3. Data validation. APIs often receive data from a wide range of sources, including third-party clients. This means that the API security must include data validation measures to ensure that the data being received is valid and does not contain malicious codes or malicious URLs. Unlike traditional web applications, where data input is typically controlled by the application itself, API must be robust enough to handle data from various sources that may not adhere to the same validation standards. This also increases the risk of malicious data being passed on to the backend systems. 4. Rate limiting or the resource management. APIs need to implement controls like rate limiting and resource management measures to prevent their abuse and also to ensure the availability and resiliency of backend services. Traditional web applications may not face the same level of risks from automated attacks and resource exhaustion as much as APIs do. By implementing rate limiting and resource management measures, organizations also protect their APIs from DDoS attacks and other forms of abuse. And lastly, logging and monitoring. APIs need a continuous monitoring and logging to detect, respond to potential security threats. Traditional web apps may rely on periodic security checks and audits, but API needs more proactive and continuous monitoring to identify and mitigate threats in real time. So let's take a look at what are the common risks and threats to APIs. This is essential for developing effective security strategies as well. First up on the list is object-level authorization vulnerability. This security weakness occurs when a request gains unauthorized access to manipulate data, and it should not have that permission to do so. A typical scenario involves an attacker tampering with a request identifier, which allows them to breach request restrictions and potentially compromise another user's account. Object-level authorization vulnerabilities can be particularly dangerous because they not only allow attackers to access sensitive data, but also perform actions on behalf of other users. Implementing proper access controls and validating request parameters can help mitigate such risks. Next is functional level authorization vulnerability. This arises when the least privilege rule isn't followed properly, typically due to complicated access control policies. This actually enables cyber criminals to carry out important commands or access areas which are meant for only certain users. Without proper checks and balances, APIs can be left to unauthorized actions, leading to security breaches and system faults. Ensuring that access controls are properly configured and reviewed can help such vulnerabilities. Third, excessive data exposure. API responses often return more data than necessary or relevant to the request. While this extra data may not be displayed to the user, this surplus information can be a goldmine for hackers looking to exploit sensitive information. By minimizing the amount of data returned in an API response and implementing proper data filtering, organizations can always reduce the risk of excessive data exposure. Fourth, improper asset management. Often rushing a release leads to teams neglecting the necessary documentation. This can result in endpoints being exposed and forgotten. Furthermore, developers may even struggle to utilize these older APIs because of unclear guidelines. Improper asset management can often lead to security gaps and vulnerabilities that will be exploited by the attackers trying to attack the moat. Next, insufficient resource management and rate limiting. If API endpoints lack restrictions on the number or size of the request, they often become susceptible to DDoS or brute force attacks. Implementing rate limiting and resource management resources can often protect APIs from this type of attacks. By limiting the number of resources that has been made to an API within a certain time period, organizations can prevent abuse and ensure the availability of services. Next, injection flaws. It's crucial to ensure that request data is properly analyzed and validated to prevent potential vulnerabilities that can be exploited by attackers. Injection flaws like a SQL injection, command injection can occur whenever an attacker is able to insert malicious code into a request and then execute it. This type of vulnerabilities often have severe consequences, including unauthorized access, data thefts, and system compromise even. Next, or the last in the list, is mass assignment vulnerability. Software development framework often provides functionality that allows all the received data from an online form to be inserted into a database or into an object with a single line of code. This is called mass assignment. However, without proper specifications, mass assignment can often lead to vulnerabilities across many attack vectors. So it is crucial to ensure that all data being inserted is acceptable by all parties and secure to prevent any vulnerability leak. For more information on this kind of security risks, you may visit the OWASP website. OWASP provides detailed information on common API vulnerabilities along with the best practices for mitigating these risks. So now that you are aware of the threats and the common API vulnerabilities, how do you deploy the moat to protect the API castle or fortify your customer data? Well, here are some essential strategies that you can use. Number one, or the most important, use a strong authentication and authorization mechanism. APIs should have a robust authex or authent mechanism, and there are several measures to do so, like OAuth or JWT, to ensure that only authorized clients can access these APIs. By implementing strong authent measures, organizations can verify the identity of clients and ensure only authex users are able to access sensitive data and perform critical actions. Additionally, using these authorization mechanisms, such as rollback access controls, can often enforce granular level controls and prevent any unauthorized access to API resources. Number two, implementing rate limiting. As we have already highlighted, APIs should implement rate limiting to prevent DDoS and other brute force attacks. This can attempt to overwhelm the API with enormous number of requests or big size requests and thereby crash the system. However, rate limiting can help ensure the availability of your backend microprocessing by limiting the number of requests that can be made to an API within a certain time frame. By preventing abuse and controlling resource usage, rate limiting can help protect your APIs from being overwhelmed by malicious attacks. Next, validate data inputs. APIs should validate the data input to ensure that the data being received is valid and does not contain malicious code or any other threats. Input validation is crucial for preventing a wide range of security vulnerabilities, which results from SQL injection or even cross-site attacks. By implementing robust input validation methods, organizations can ensure that only properly formatted and safe data is accepted by an API. Encryption. API should use encryption to protect the data in transit and also the data at rest. This will ensure that the sensitive information is not exposed to authorized or unauthorized parties without their permission. By encrypting data transmitted between clients and servers, organizations can protect against eavesdropping and man-in-the-middle attacks. Additionally, this encrypted data that is stored in the database and other storage systems can also help against data breaches and brute force unauthorized attacks. Next, monitor and log. API should be continuously monitored and logged to detect and respond to potential security incidents promptly. Logging and monitoring are essential not only for maintaining visibility into the API activity and identifying potential threats, but also by detecting anomalies and maintaining an audit trail of all interactions. Can organizations investigate the security incidents, take corrective actions, and eventually improve their overall security posture. Implement security testing is another important step out here. This which is also known as the DAST and a regular SAST, includes vulnerability assessment and pen testing, which can help identify and address security weakness in your APIs. By conducting this thorough security testing, organizations can uncover vulnerabilities that are otherwise not apparent during development and can take steps to mitigate them before they can be exploited in the wild. Last is, and the most crucial point out here, which is educate and train your developers. Ensuring that the developers are knowledgeable about API security best practices is as crucial for preventing security measures as implementing the moat. By providing ongoing education and ongoing training, organizations can equip the development teams with the necessary skills and knowledge needed to build secure APIs. So as we reach to a conclusion, we see the digital landscape is actually fraught with evolving threats, making API security a critical and ongoing endeavor. Thorough, vigilant monitoring, proactive risk management, and the adoption of advanced security measures are required to safeguard APIs in an organization. By understanding the unique vulnerabilities of APIs and implementing robust security protocols, businesses can also protect their data, maintain their customer trust, and support seamless digital operations. API security is not just a one-time effort, but an ongoing process that requires continuous attention and continual improvement. As new threats emerge and technologies evolve, organizations must stay vigilant and adapt the security measures to address changing risks. By fostering a culture of security, investing in the right tools and technologies, and maintaining a proactive approach to risk management, organizations can protect their APIs and ensure the overall security and resiliency of their digital ecosystems. So that's all we have from today's API security and basics. If you want to know more of this domain and also how Rakuten SixthSense can aid in securing your APIs from data exfiltration and other emerging cybersecurity threats, please do check our website at sixthsense.rakuten.com or contact us through the same. We'll be happy to assist you with your queries and help you fortify your digital interactions. So once again, thank you for joining us today and stay secure. As we conclude, remember the key to robust API security lies in continuous learning, vigilance, and proactive risk management. The digital world is ever changing, and so are the threats. So stay informed, stay prepared, and most importantly, stay secure.